Our next topic is velocity time graph. And for the aforementioned topic, I have selected the first question from paper 9709/41 for the session May June 25. And we are going to solve question number 3 under this concept. Let's see what the question says. It says that diagram shows the velocity time graph of the motion of a cyclist. The graph consists of three straight line segments. The cyclist passes over a point O with speed 3 meter per second and then accelerates for 10 seconds with constant acceleration of 0.5 meter per second. He then travels at a constant speed for 30 seconds before decelerating, coming to rest at point P, covering a distance of 80 meters whilst decelerating. Find the total time taken for the journey from O to P. Well, this is what the question is, and we are going to find the total time 40 minutes until 40 minutes it's given. Then we are going to find the final time instant when it came back to rest. So for knowing the time, the final time instant when the particle or the cyclist came to zero is this point. We should know this timing as well as we should know the velocity this point. Okay, this point should be obtained. So for first part, I mean this V, we can easily apply this first segment. What is it written about? For the first segment, that means for first 10 seconds, it is written the particle was accelerates at the rate of 0.5 meter per second for 10 seconds. So analyzing this information, we can find our velocity. And we know the formula, Shubert formula for velocity is V is equal to U plus AT. Okay. Then we require V. Let us substitute the values we do have. Initial velocity of the cyclist was 3. So let us write 3 plus, as it was accelerating at the rate of 0.5 and the duration was 10 minutes. So 0.5 into 10. Finally, we have got that our velocity is going to be V is equal to 3 plus 50. So 3 plus 5, sorry, it is going to be 8. V is equal to 8 meter per second. Okay. So for the first 10 seconds, the velocity was 8 meter per second. So hence, we can write here 8. Well, so this point is also 8. Okay. Then we will have to find that they have told that total distance. Look at this. When it was decelerating, the total distance traveled by this cyclist was 80 meter. And let us suppose it to be T. And the first part was for what was the time 0 until 0 until how long? First 10 seconds. And then we will find for the last phase for, I think I can change the color of the stylus. It is for the second phase, I mean third phase. For 40, it starts from 40. So 40 until, let it be T. Let this moment be T, I mean uppercase T. The distance is written, the distance is equal to, distance traveled is equal to how long? It is written 80 meter per 80 meter. So let us write 80 over here. Then if we calculate this, we know the distance of this shaded region, area of the travel distance. So area of this is triangular part. So for triangular part, we will apply the formula of half into base. Base is actually t minus 40. T minus 40, and height is actually, this is height. Okay, so already we have found that this is 8. 8 is equal to 80. Well, then if this half multiplies 8, it is going to be 4. If 20 is divided by 4, it is going to be 20. If 8 is divided by 4, it is going to be 20. T minus 40 is equal to 20. Hence, finally, our T is going to be, T is 40 plus 20, it is 60. That means our final time when the cyclist came back to zero was 60 seconds. Okay, they have told us to find the value of t, so second needs not to be written, already it is with the quantity. So that's all about the solution to the first part of this question, and it's not difficult at all. It's one of the easiest questions of the aforementioned topic. Okay, they have told us to find the total time, so we can write one more step. So let it be written, total time is equal to, total time, total time is equal to 60 second. 60 second, let it be lowercase, 60 second. Okay, that is what our final answer. Now let's see what the question number B says. Part B says, on the given axis, sketch a displacement time graph for the cyclist journey from O to P, showing on your graph the distance traveled after 10 seconds and 40 seconds. So they have given a velocity time graph, whereas we'll have to convert it into distance or displacement time graph. For that, as there are three different phases of the journey, so we'll have to find one after the other. Let's start with the first part. The first part was for 0 until 0 until 10 second. It was the first phase of the journey. Let us see what was until 0 until 10 seconds. The displacement was given, s is equal to, we know we are going to apply the displacement formula, because we should know what was the shape of the curve. Okay, because we cannot copy velocity time graph for displacement time graph, they are absolutely different from each other. So we should know actually how is the shape of the displacement curve or graph. S is equal to, our formula is ut plus half a t squared. Okay, then initial velocity, we are going to see the question again. This was the question. Look, initial velocity was for the first 10 seconds. Initial velocity, look, initial velocity was 3 and acceleration was 0.5. Initial velocity was 3, acceleration was 0.5, time was 10 seconds. So we can substitute these values. So our s is going to be, s equal to, initial velocity was 3t plus acceleration was 0.5. That means half into, again 0.5 means half t square. Actually we are going to know the shape of the graph, we don't need to find the value, exact value. Exact value is also necessary, displacement, but let us see the shape of the graph, because if we don't know the shape of the graph, whether this is straight line or curved line or quadratic or cubic function, then how will we start our drawing? That's why we are going to get, it is going to be 1 over 4, 1 over 4 t square plus 1 over 4 t square plus 3t plus 3t. So what will be the shape of this? This is actually quadratic graph and positive, and there is no, it must pass through zero because there is no constant number. So this is going to be actually u-shaped, that means positive graph starting from the first second quadrant, u-shaped quadratic quadratic curve, quadratic curve. So we have got the shape of the first part for the first 10 seconds. Okay, then let us see, we require to know the displacement also. Okay, so displacement is equal to distance. Let us write here, distance is equal to, applying the same concept we can find this. Initial velocity was 3 and time was 10 seconds, so 3 into 10 plus our half, acceleration was also half, and time was 10 seconds, time was 10 seconds, applying the same concept. Or you can find the total distance traveled in the first 10 seconds by applying the concept of the area of the triangle, because first not area of triangle, it was trapezium. So finally it is going to be 30 and here 125, so it is 55 meters. So for the first phase we have found the expression of displacement as well as the distance traveled by the cyclist. This is the first part. Then the second phase, let us see what was the second phase. The second part is this, actually this part. Okay, this part is actually a rectangular shape, and this height is width is, we have already got, it is 8, and then our this length is 10 to 40, that means 30. So 30 into 8, it is simply 30 into 8. So let us write for 10 until 40 seconds. For 10 until 40 seconds, as I have shown, it is just a rectangle. So this, first of all, we will have to form the expression S is equal to Vt. Okay, Vt, because there was a constant velocity and V was 8, so that is 80. Then what does it mean? It is simply a straight line. Okay, V is equal to S is equal to Vt. That means this is a straight line which will, as there is no constant number, so it will also pass through the origin. So straight line, it is also a straight line, straight line. Okay, then let us find the distance. Okay, distance is distance distance is distance, applying the same concept, 8 into t was 10 into 40, it was 30, isn't it? It was 8 into time was, we have already written, for 10 until 40 seconds means 30 seconds. So it is equal, distance is equal to 830 is 240 meters, 240 meters. Look, this 240 meters was the distance traveled in 30 seconds, but this is not the total distance until 40 seconds. So we will have to write the total distance in 40 seconds, total distance, total distance means the previous distance should also be added. Total distance, total distance is equal to, initially first there were 55 meters. Okay, now it has traveled to 40 meters, so it is total distance in first 40 seconds is going to be 295 meters. 295 meters is the distance traveled in the first 40 seconds. Then the third phase of the journey. Third phase of the journey, we came to know from the previous graph that total time was 60 seconds when he was he came back to rest again. So for 60 seconds means 40 until now, 40 seconds until 60 seconds. Okay, 60 seconds. Let us see what is written about the final phase of the journey. It is written, look at this. For the final phase, for the final part of the journey, actually they didn't mention, look at this. He then travels at a constant speed for 30 seconds before decelerating, coming to rest at point P, covering a distance of 80 meter whilst decelerating. So distance is given, but they didn't mention the deceleration rate. So we will have to find first the deceleration of the final part. That's why we will have to apply the concept of v is equal to u plus at. So v equal to u plus at. Okay. So final velocity, he came to rest. So final velocity is 0. Initial velocity was 8 because from 8 it was coming downward, and acceleration is to be obtained and time was 20. Already we know that this is 20. Okay. So our a is going to be negative 8 over 20 meter per second square. 20 meter per second square. This is our acceleration. As we know the acceleration and time taken by the cyclist, we can find now s. Our s is equal to the same concept we are going to apply. S is equal to ut plus half a t squared. Okay, so displacement is going to be, initial velocity was 8 and time taken by the cyclist for coming to rest was 20, because 40 until 60 means 20, 20 plus half of it is negative because he was decelerating. Our a is having negative value, so minus half of acceleration was negative 8 over 20, 8 over 20, and our time was 20 squared. 20 squared. So how much is it going to be? For the final phase it was 160, and 400 divided by 1040. So 160 minus 80, it is going to be 80 meter. Okay, it is 80. From 160, if we subtract 80, it is going to be 80 meter. This is the distance traveled in the final phase, and we will have to find, let me rewrite it taking less space. So this 80 meter was the distance traveled in last 20 seconds, but what was the total distance? So let us write total distance. Total displacement, total distance is, initially we have found that in the first 40 seconds the distance was, in the first 40 seconds there was a distance traveled, it was 295, and in the next 20 seconds it was 80. So 295 plus 80, it is going to be 275 meters. 275 meter was the total distance. And now we are going to know the shape of this graph. So s equal to u. Initial velocity was 8t and acceleration due to gravity was negative. So negative, it is going to be half a was 8 over 20. So for 1 over 5, 1 over 5 minus 1 over 5 t square. That means negative 0.2 t square plus 8t. Okay, so what will be the shape of this? It will be, it is also a quadratic graph, but it is negative. So shape of the curve is going to be, it will be just negative graph starting from the third quadrant, and U-shaped, that is N-shaped, N-shaped quadratic, quadratic graphs, quadratic curve. Okay, so quadratic graph. So we have got all three graphs. Now easily we can start our drawing. So first one was this U-shaped quadratic curve, and the second one was straight line. This one was straight line, and then the final one was U-shaped, that means negative quadratic curve. So let us start writing. For the first one, the time phases are first 10 seconds. Let us write the time. First horizontal axis 10, 40, and finally it is going to be 60. Until 40 they have already given. So let us write here 60. It is 60 when he came back. Well, now the displacement. So first displacement was, it was how long? 55 meters. So let us write here 55 along the vertical line. 55, let us see, first one was 55, second one will be 295, then finally it will be 275. So these three values should be written across the vertical line. Okay, that means displacement line. It's not 275, it should be actually 375 meters. So first of all, on top we are going to write 375. Our labeling has been done. Now we are going to draw the graph. Look at this. When the time was 10 seconds, then distance was 55. So let it be a point. Then when time was 40 seconds, distance was 295. Then when time was 60 seconds, our total distance was 375. Let it be over here. It is assumption. Remember, I am not writing using scale or any other measurement tool. So first one, look at this. First one is U-shaped. We have already written here. It is U-shaped quadratic graph through origin, because it will go through origin because there is no constant number. So how will it look like? It will look like this. Okay. Then for the second phase, it was straight line. Already we have written here. It is a straight line. So this will be the straight line. After that, finally the final curve is also a quadratic curve, but it is negative, that means opposite to you. So it will look like this. Somewhat it will look like this, and let me show you once again. So finally your distance time graph will look like somewhat this. It may not be exactly accurate, but it will be somewhat similar to this. First part is sorry, third part has been first part has been drawn wrongly. Let me draw once again, because it was U-shaped. First part was U-shaped. Yes, the curve will look like this. First part is U-shaped, positive quadratic graph. Second one is straight line, and final one is again negative quadratic graph, which will start from the third quadrant. So this is how the curve will look like. Let me show you the previous part. The previous part was this. Okay, finding only the time, but it took much time to draw the curve, because drawing the curve on the display is really difficult on the drawing on the screen. Well, let's move on to the next question. The next question we are going to solve belongs to paper 9709/42 for the session May June 25, and we are solving question number 4. Let's read it. A car is traveling along a straight horizontal road. The car passes through a point A on the road traveling at a speed of 15 meter per second, and then accelerates uniformly at zero point 0.4 meter per second for 30 seconds. The car then moves at constant speed for 3t seconds, where t is less than 30. The car then decelerates uniformly at zero point 0.2 meter per second square, and after a further t seconds passes through a point B on the road. So there are actually three phases of this journey also. Question number 8 says, on the given axis, sketch a velocity time graph for the motion of the car between the points A and B. Well, as there are three turning points, I mean three phases of the total journey, initial velocity is given, it is 15, but when it was accelerating, we don't know the velocity at that time. So we will have to find the velocity for v is equal to when it was accelerating for 4.4 meter per second for 30 seconds. So let us find the velocity, because we are drawing velocity time graph. B is equal to v is equal to u plus at. Okay, velocity is to be obtained of v is going to be u. Initial velocity was 15 and acceleration was zero point 0.4 and time was 30 seconds. Hence our velocity is going to be 15 plus 12. 15 plus 12 is 27. So 27 meter per second is the velocity when it was accelerating. So let's mark the points. The time velocity was, first one was 15. 15, it started from origin at the speed of 15, and when it accelerated it was 27. So let us write here 27, 27, 27. Okay, and time was, first it was for 30 seconds. First one was, let it be 30 over here, 30. First phase was for 30 seconds, and it was traveling at constant speed for 3t seconds, 3t seconds. So here it may be 30 plus 3t, 30 plus 3t. Okay, then the car then decelerates uniformly at zero point 0.2 meter per second, and after a further t second passes through a point B on the road. Then for the final phase, the car then decelerates uniformly at zero point 0.2 meter per second, and after further t seconds. So there will be another t. So 30 plus t, again t, 30 plus 3t. It is not t actually, it should be 3t. 30 plus 3t. So let me write here 3t, 3t. Then again after t seconds, it was decelerating and passing through a point B. So 3t plus again 1t, so it is going to be 4t. 30 plus 30 plus 40. It is 30 plus 4t. Okay. Then we are going to complete our diagram. Let me erase these unnecessary parts. So first 30 seconds, its acceleration was, velocity was 27. So let us write here 27, yes, at 30 seconds. Then it was moving at a constant speed until 30 plus 3 seconds, 30 plus 30 seconds. Then it continued until this point, that means decelerating. Okay, but we don't know exact velocity when it was decelerating. So how to draw this? We will just join this, because this was everywhere there was uniform acceleration or uniform velocity or uniform deceleration. That's why everyone will be a straight line. Remember, there should be no curve, because this was uniform acceleration, uniform velocity and uniform deceleration. That's why there is no scope of curved line. Please let it be noted that curved line is for ununiform. If there is variation in the velocity or acceleration, then there is curve. As this is uniform, everyone look at this, the first phase was acceleration, uniform acceleration, and second one was constant speed, uniform speed, and the first phase is also uniform deceleration. That's why first phase will also be a straight line. Every three, all of this three part will be straight lines. Then as we don't know that when it has reached to zero, that means came back to rest, that's why it will be a dotted line, not solid line. We cannot, and you can even avoid this dotted line is not even necessary. Let me show you again. So this is our graph. So from here 30 to 30, this is going to be 3t, this portion is 3t, and from here this portion, if we connect these points, then the time span between this 30 plus 3t and 30 plus 40, this is actually t. Okay, now we are, this is what about the first part of the solutions. Then let's see B, what B says. Question number B says the distance from A to B is 2750 meter. Find the value of t. So we know the distance is actually sum of the area traveled by the particle or cyclist or car, whatever. Then we will have to find the area of other part. Also there are actually three parts. So let us draw the other part. This is going to be over here. Okay, yes, this one. So we can start writing our solution as total distance. Total distance is total distance is equal to, as they have given, is 2750 meters. So for the first phase, it is a trapezium. First one is a trapezium. So we will have to write the area of trapezium, which is, or area of trapezium is, half of this base. Base is 30, and then the sum of the parallel lines. One line is 50, and the length of height of another one is 25, 27, 27. Okay, I think before starting our solution, we should know the height of this distance. Okay, this height should be known to us. That's why we will have to find that height, the velocity at that moment when it was decelerating. For the first phase, it is already given. For, we can write here, for 0 until 10 seconds, for 0 until 30 seconds, our v is equal to 27 meter per second. Already we have collected this from the first part. Now for this, for 30 plus 3t until 30 plus 40. Okay, for the third phase, for 30 plus 3t seconds until 30 plus 40, 30 plus 40, it is uppercase t actually, as they have mentioned. So v is equal to u plus a t. Okay, then our velocity was, final velocity is not known to us. Initial velocity is known to us. Initial is this height, this is known to us, it is 27. So 27, as this is decelerating, though, so symbol will be different, and deceleration rate is given here. Look, it was decelerating at 0.2 meter per second. So it is 0.2, 0.2, and then t is actually difference between 30 plus 40 and 30 plus 3t is, it's actually t, this uppercase t. So this is the velocity at the final stage, 27 minus 0.2 t. Now we can apply the concept of a Schubert formula distance. So total distance is equal to total distance is equal to 2750 meter. So for the first phase, it is, if we see carefully, we'll find the first phase is a trapezium. So trapezoidal area is half of our time is 30 seconds, so 30, and the summation of the parallel sides, one is 50 and the other one is 27. So 50 plus 27, 27, 50 plus 27, plus the second phase. Second is it's a triangle, sorry, rectangle. So rectangle is base into height. Base is 30 plus 3t minus 30, so it is 3t, 3t, and our height is 27, 27. Now for the third phase, okay, for the third phase, here we have already found that this is velocity is 27 minus 27 minus point 2 t. Okay, so we are going to write this is also trapezoidal distance, that is half of the distance between these two. Look at this, 30 plus 3t and 30 plus 4t, it is actually just t. Okay, so t, then sum of the parallel sides, one is 27 minus 0.2t, another one's 27, so we will just write 27 plus. So this is how our step. Now if we simplify, it is going to be 20, 27 plus 15, that is 42. 42 over 2 means 21. 21 into 30, that is 6300. It is going to be 630. 630 plus 327s are 81, 81 t uppercase t, plus here what is it going to be, 27 plus 27 means 54, 54 over 2 means 27, so 27t, 27t, 27t minus, if we divide zero point 0.2 by 2, it is 0 0.1, 0.1 t square, 0.1 t squared is equal to 2750, 2750. Now I will have to take some space to complete this. Equal to 2750 is our right hand side. Now if we simplify this, it is going to be 81 plus 27, that is 108t, and negative 0.1 t square, negative 0.1 t square plus 108t plus, it is not plus, from 2750, if we subtract 275, if we subtract 763 from 275, it is going to be 212, 212, then 0, it is going to be 0 right side. Now if we multiply every quantity by 10, it is going to be t square, and we are dissolving the negative symbol, t square plus, sorry, minus 1080t plus 21200. Now if we break up the middle term, it may be t square minus 1060 minus 1060t minus 20t plus 21200 equal to 0. Hence we can, if we factorize, it is going to be t minus 1060 into t minus 20 is equal to 0. Hence our t is 20. Now you may ask that how can we reject that t is, it is less than 30. I am going to show you the part of this condition. Hence our t is 20. Answer is, they have told us to find the total t, the value of t, I think they have told us to find. So which is our answer? It is our answer. Let us see whether they have told us to find t or not. Yes, they have told us to find the value of t. Now, why are we rejecting the value which is 1020? Look at this here. It is distinctly written t must be less than 30. Okay. So, our t acceptable value of t is just 20. This is t is equal to 20. That's all about this solution. Let me show you the previous question, previous solution again as a whole. This one. Okay, here we have got the we have drawn the velocity time graph. After that, we have found the value of t over here. Now let's see one more question. The next question has been selected from paper 9709/43 for the session May June 25, and we are solving question number 3, which belongs to our topic of velocity time graph. So let's see what it says. It says the diagram shows a velocity time graph which models the motion of a particle. The graph consists of 3 straight line segments. The velocity of the particle at time t second after passing a fixed point O is v meter per second. The particle leaves O with a velocity of 5 meter per second and accelerates at 0.75 meter per second square for 20 seconds. The particle then decelerates for the next 30 seconds at t equal to 40. The velocity of the particle is 0. After t is equal to 40, the particle starts to travel back to O, coming to rest at O at time t seconds. So from this graph, it's not complicated at all. First of all, they have told us to find the value of t. That means here, what is the time when the particle went back to 0? I mean, it came back to rest. Okay. So for first of all, what we should know that what is the velocity at this point when it was accelerating, and what is the velocity at this point when it was decelerating. Well, so for the first one, we can find applying the concept for the first. Let me erase this. For first 20 seconds, it is acceleration is uniform, so v is equal to u plus 80, and initial velocity is 5. It started from 5 meter per second, plus acceleration is given 0.75 meter per second square. So 0.75 meter per second square, 0.75 meter per second square into time is 20 seconds. So first velocity is going to be 5 plus 15 means 20 meter per second. 20 meter per second is the velocity at the first 20 seconds. Okay, so let us write here, it is going to be 20. Okay, now we should know this. This one, for this above this I can write here, for this is for first 20 seconds. Now for second 20 seconds, I mean for 40 seconds, we'll have to find the acceleration. For, let us write, for the time is 20 until 20 second until 40 seconds. 40 seconds. This is also a deceleration. We are going to apply the same concept. V is equal to u plus 80. So what is our velocity? We have got that velocity was 20. Let us see, velocity was 20. From 20 it was decelerating. So 20 equal to initial velocity, sorry, final velocity is 0, because when it was at this point final velocity was 0. So it is going to be 0 is equal to initial velocity was 20 plus acceleration is to be obtained. So a and t is, how much is t? T is from 20 until 40, it is 20 seconds. Hence our a is going to be, it is deceleration, so definitely it is negative. If we divide 20 by 20, it is negative 1. Okay, so our deceleration is negative 1, acceleration is negative 1. Hence we can find this point. Okay, So v is equal to, again v is equal to u plus at. Okay, our velocity is to be obtained. Initial velocity is 0 and acceleration was negative. Time is how much? Acceleration is -1, we have just found 1, and time is 10 seconds. It took 10 seconds to reach this velocity, so it is 10. Hence our velocity is going to be -10, -10. Okay, so now we can write here it is actually -10, -10. So we have got all of the information. Now easily we can find the value of t, and we are going to apply the concept of what Subert formula, I mean distance formula. So distance traveled. Look, once again, let me clarify. You may get confused that how is the distance. Look at this. The particle was moving onward. The particle was moving onward and it has traveled a distance, suppose s. And as the particle is going back to origin, then definitely the distance it moved on and moved backward must be same. Okay, it started from here and again came back to this point. So the distance before, distance in the travel in first 40 seconds, in the last time means of t minus 40 seconds, it must be same because it went back to o. Let me show you. It is written, look at this, it coming to rest at o again. It started from o. Look at this, a particle, it starts from fixed point o. It started from o and it came back to o. So definitely the distance is its travel in the first 40 seconds. I mean this area must be equal to this area. Okay, upper part contains two parts. One is trapezium, up to this it is trapezium, and second part is triangle, and lower part is only one triangle. So we are going to apply the concept that distance is going to be distance traveled, distance distance traveled, distance traveled in first 40 seconds, traveled in first 40 seconds, first 40 seconds, 40 seconds must be equal to distance traveled in, distance traveled in. Yes, I have written over here so that it's shows better. Then distance travel in first 40 seconds. In the first 40 seconds there are actually two shapes. One is, first one is trapezium, this one is trapezium, and second one is triangle. So first, for trapezium it is going to be, the area is half of, the time is 40 seconds, half of 40, and then sum of the, not 40 seconds, it is a trapezium covered 20 seconds I think, so it is going to be 20 actually. Let us write 20. It was 20. Then the sum of the parallel sides, first side is, this is 5 and this is 20, so it is 25, 25, 25, 25. Then the sum of the area of the triangle, I mean area of the triangle is half of our base is how much? Base is 20 to 20, so it is 20. 20 to 40 means 20. Then height is same, it is 20. Maximum velocity is the height 20. So 20 equal to right side. In the right side, distance traveled in the t minus 40. T minus 40 is this triangle. So this triangle is half of base is, height is already we have found it is 10. Negative velocity was 10, and our base is t minus 40, t minus 40 seconds. Okay, so equal to, if we calculate this, it is going to be 250, and that is 400 up, so 450. It is 450 on the left side, and on the right side it is going to be, on the right side, if we divide 10 by 2, it is 5. So 5t minus 5t minus 400. Sorry, 540 is 200. It is 200. So 5t is equal to, if we, let me write over here, or 5t is not there. Just let me write just beside this over here. So our 5t is equal to 5t equal to, we have 450 plus 200, so it is 650. 650. Then if we divide 650 65 by 5, it's 13, so t is equal to 130. So our value of t is 130. Okay, now let's see what v says. I mean, question number b says, question number b says, here is B. Okay, so B says find the acceleration of the particle from t until 40, t until uh, 130, t is equal to 30. So we can apply the concept, the simple concept, v is equal to, this is for B. Okay, for B, and our concept is b is equal to u plus a t. Okay, the final velocity is going to be, final velocity is to be 0 because it came back to rest, and initial velocity was negative 10. Look at this, initial velocity was negative 10, and plus a, our a is to be obtained, and t is our, here t was 130. So from 130, if we subtract 40, it is going to be actually 90. So let it be 90 over here. Okay, then how will it look like? Let me change the ink actually, so that it's distinct. So from it is actually t was 130, and they have told between 50 and 130, so it is 80. Hence our a is going to be, a is equal to 10 over 80. 10 over 80 means 1 over 8. Okay, if we divide 1 by 8, it is going to be, a is equal to 0.125 meter per second square, meter per second square. So this is what the acceleration of the particle in the time between 50 and 130 seconds. So that's all about today's topic, velocity time graph, and I tried my level best to explain every tiny part. And thank you all for watching this part as well. Fi amanillah.